Welcome back to Step to Step Electrical friends. Now we are here to discuss on nodal analysis, and this is the part 3 of nodal analysis. So let's start, and the title of this video is nodal analysis of the circuit containing voltage source along with the current source. So in this section we will discuss on source transformation, general analysis, solution of a numerical, verification of the numerical using circuit lab. Now you can see that this is a circuit. In this circuit there are two current sources, I2 and I3, and along with these current sources there is a voltage source. And now we have to convert this voltage source into current source. So the first step that we have to do is source transformation, and this source transformation is done with the help of using Ohm's law. Nothing, just use I equals V by R. Now as V and R is known, and using I equals V by R, we can easily find out the magnitude of the current source. Let's draw the circuit. Here this is the current source Is we have obtained from V and R using the formula I equals V by R. So one thing that you have to note, this voltage source is transformable into current source. Why? Because there is a resistance in series with this voltage source. And after transforming this voltage source into current source, one thing that you have to do is, here this resistance is in series with this voltage source. Now we have to connect this resistance in parallel with this current source. So this is all about source transformation. This is the final circuit we obtained after the source transformation, and now you can see that there are only current sources. There is no any voltage source, and you better know how to deal with type 1. If you haven't watched the video, just go and watch the video. Okay, so first of all we will apply KCL at. So before applying KCL we have to assume. So here let A, B, C and D be the nodes. This is A, B, C and D are the nodes, where D is the reference node, and these all are at a common point. So we assume D as the reference node. So let's ground it. Okay, and one thing that you have to assume is the voltage of each of the nodes. So let VA, VB, VC and VD be the voltage of the nodes A, B, C and D respectively. And now as we see that the node D is grounded, so we can easily write VD is equal to 0 volt. So VD is equal to 0 volt. So let's apply KCL. Now we will apply KCL at node A. Remove all the elements and branches that have no concern with node A while applying KCL at node A. So let's remove, and here as we remove we get this. So before writing the KCL equation, the first thing that you have to assume is that which one of these currents enter the junction, which one of the currents leave the junction. So first of all, let's assume that Is is the current which enters the junction, while the current through this resistor Rs, R1, R2 and R6 leave the junction. And you can assume according to your wish. There is no any restriction, but I have assumed Is as the current which enters the junction, while the currents through Rs, R1, R2 and R6 which leave the node A. So let's write the KCL equation, and here the KCL equation is IRS plus IR1 plus IR2 plus IR6 is equal to Is. Now we have to replace this current with its equivalent value using Ohm's law, that is I equals V by R. For IRS we can write, this one is Rs and the current flowing from A to D, and the VD is equal to 0 volt. So we can write VA minus 0 upon Rs. For IR1 we can write VA minus 0 upon R1. For IR2 we can write VA minus VB upon R2. And for IR6 we can write VA minus VC upon R6 is equal to Is. Here Is is same. Why? Because the value of Is is known. So this is the first equation. Friends, it's a request, if you are watching this video and you find this video interesting, exciting and helpful, like this video, and if you haven't subscribed this channel, please subscribe this channel. Here we will apply KCL at node B. So applying KCL at node B, before applying, let's remove all the elements and branches that have no concern with node B. So here it is. Now we will get this. Okay, applying KCL, we will assume which one of them are entering the nodes and which one of them are leaving the nodes. So here we assume I2 is the only current which enters the node, while the current through R4, R3 and R2 which leaves the node B. So let's write the KCL equation, and here it is IR2 plus IR4 plus IR3 equals I2. IR2 current from B to A through R2. IR4 is the current from B to D through R4, and IR3 the current flowing from B to C through R3 is equal to I2. This is the KCL equation. Now we have to replace with its equivalent value. So let's replace it. Here I2 can be written as IR2 can be written as VB minus V upon R2, IR4 VB minus 0 upon R4, and IR3 VB minus BC upon R3 is equal to I2. How we write and why we have written this, you better. Okay, so this is the second equation. Now let's apply KCL at node C. Again here we will remove all the elements and branches that have no concern with node C. So you get this, and now again here we will assume which one of the current is entering the node C, and which one of the currents leave the junction. So assume I3 as the current which is the only current which enters the node C, while the current through R5, R3 and R6 leave the node C. Okay, so let's write here IR3 plus IR5 plus IR6 is equal to I3, and this is the KCL equation. Now it's time to replace this KCL equation with its equivalent value, and here it is Vc minus Vb upon R3. This is the R3 resistor, and current is flowing, I3 current flowing from C to B, so we can write Vc minus Vb upon R3. And for IR5 we write Vc minus 0, Vd is equal to 0, so Vc minus 0 upon R5, and for IR6 we write Vc minus V upon R6 is equal to I3. So we have also obtained the third equation. And now we have three equations, equation first, equation second and equation third, and now on solving these three equations we can easily get the values of VA, VB and VC. So this is the general analysis for the circuit containing voltage source along with current sources by nodal analysis. This is the given problem, and here we see that 5 ampere current source and 8 ampere current source. There are two current sources, but there is a voltage source of 20 volt. And the very first thing that you have to think of is this voltage source can be transformable into current source or not. Yes, you can see that there is a 4 ohm resistor in series with this voltage source. There is a 4 ohm resistor in series with this voltage source. If there is a voltage source in series with the resistor, then we can easily transform the voltage source into current source. Again you can see that there is only current sources. Now this type 2 has become type 1, and you better know how to solve type 1. Okay, so let's apply KCL, and before applying we have to assume something like the name of the nodes. So let A, B, C and D be the nodes where D is the reference node. Similarly, we will also assume VA, VB, VC and VD are the voltage of the nodes A, B, C and D respectively, where VD is equal to 0 volt as we have discussed earlier. Okay, so here let's apply KCL at node A, and here again we have assumed 5 ampere is the only current which enters the node A. So we can write I4 plus I8 plus I4 plus I6 is equal to 5. I4, I8, I4 and I6 is equal to 5. And on simplifying we can write 0.792 VA minus 0.25 VB minus 0.167 VC is equal to 5. So this is the first equation. Applying KCL at node B, here I4 plus I5 and I8 are considered as the current leaving the node B. Here I4 is VB minus V upon 4, I5 is VB minus 0 upon 5 and I8 is VB minus BC upon 8 is equal to 5, and on simplifying we can write minus 0.25 VA plus 0.575 VB minus 0.125 VC is equal to 5. So this is second equation. And finally on applying KCL at node C, you can write I8 plus I6 plus I6 is equal to 8. Similarly, on simplifying this equation, you can write minus 0.167 VA minus 0.125 VB plus 0.4583 VC is equal to 8. Coefficient of VA is positive while applying KCL at node A, and here while applying KCL at node B, the coefficient of VB is positive. While applying KCL at node C, the coefficient of VC is positive. Why? Think of this. As we have applied KCL at node A, we have assumed that node A has the highest potential. And once we were applying KCL at node B, we have also assumed that node B has the highest potential. Similarly, once we were applying KCL at node C, we have also assumed that node C has the highest potential. That's why we obtain, while applying KCL at node A, VA is positive. While applying KCL at node B, VB is positive. And while applying KCL at node C, VC is positive. So let's solve these equations, and we will get VA equals 20.78 volt, VB equals 24.63 volt, and VC equals 31.75 volt. This is the value of the voltage, node voltages, VA, VB, and VC. Now it's time to check this value. Is this value correct or not? So now you can see that this is a circuit and which we have solved and obtained this result. Now we have to verify is this result is same or not. And you can see this is the same circuit that is here. So let's check. You can see in the result the VA is 20.78, but here in lab it is 20.81 volt. In result it is VB 24.63 and here it is 25.5 volt in circuit lab. So again here it is approx. Okay, in result it is 30.75, here in lab it is 30.59 volt. Finally VD is 0 volt. You also know, as we have considered VD is equal to VD is either reference node, so it is 0 volt. So in this way we have verified the result and our result is 100% correct. So thank you friends for watching this video, and if you found this video interesting, helpful and exciting, like this video and share this video with your friends and drop your valuable comment in the comment box. And if you haven't subscribed this channel yet, please subscribe this channel. Hope to see you in next video.